Okay, I want to do some proofs of trig identities that involve fractions in various forms, and I will make some assumptions about your current trig identity knowledge, such as knowing the Pythagorean identities and how to write all the trig functions in terms of sine or cosine. So the first problem we want to do, the first example we want to look at, is we want to prove that cosine of x over secant of x equals 1 minus sine of x over cosecant of x, okay? And so let's take the approach that, we can see that we could do some work on the left-hand side. So let's go ahead and work on the left-hand side here, rewriting secant of x as 1 over cosine of x. And so this is what we call a complex fraction, but now what I have to do is divide cosine of x by this fraction, which is the same thing as multiplying cosine of x by the reciprocal of this fraction. Right? If you want to divide by a fraction, you multiply by its reciprocal. And so cosine of x as a fraction itself, I could put over 1, and if I multiply these together, I just end up with cosine squared of x over 1, which is cosine squared of x. So we're going to leave the left-hand side alone for now because it's pretty simple, and work on the right-hand side. Now similarly, on the right-hand side, I could do the same sort of idea with this sine x over cosecant x and write it as 1 minus sine x over 1 over sine x. And so that's the same thing as sine x times sine x over 1, which is sine squared x. And now 1 minus sine squared x through maybe the first Pythagorean identity that you know is the same thing as cosine squared of x. Therefore, the left-hand side equals the right-hand side, and that's the end of the proof. Okay? So this proof was about rewriting your secant and cosecant and then knowing how to divide by a fraction. Okay? And also implementing your Pythagorean identity. Let's see another example. Let's say that I want to prove that cosecant of theta minus sine of theta equals cosine theta times cotangent theta. So let's see what we've got here. When I look at the left-hand side, I've got a minus, and I'm already thinking of cosecant of theta as a fraction. So on the right-hand side, I have no minus or plus. So my approach is going to be to take the two terms on the left-hand side and combine them as fractions. Okay, so that's the approach we may take here, because cosecant of theta is the same thing as 1 over the sine of theta, and sine of theta is the same thing as sine of theta over 1. And now I can put those together with a common denominator. So I want this fraction to have a denominator that matches this denominator. So I do that by multiplying the bottom by sine of theta, because that's going to give me sine of theta when I multiply to match this denominator. But if I multiply the bottom by sine of theta, I have to multiply the top by sine of theta also. And so the result is 1 over sine of theta minus, when I multiply these, on top I get sine squared of theta, sine of theta times sine of theta, and on bottom I get just the sine of theta. And now my denominators are the same, meaning I can subtract my numerators to have 1 minus the sine squared of theta over the common denominator sine of theta. So now I've put my fractions together. So what we could do at this point is we've at least put the fractions together. Maybe we can come back and do some more work, but let's go look at the right-hand side and see if we can change the way it looks. And you may see some things you can continue to do on the left-hand side. There are lots of paths you can take to a correct proof, okay? So the right-hand side, I've got cosine of theta times cotangent of theta, which is cosine theta over sine theta. To multiply those, I'll put cosine theta over 1. So that gives me cosine squared theta on top over sine of theta. And so now I'm just kind of looking back and forth between what I have here and what I have here, and I notice that my denominators are the same. So that's a hint that my numerators should be the same as well. And in fact, we just saw in the last video, I believe, or the last example, that 1 minus sine squared is, in fact, cosine squared. So now we'll come back over to the left side, and I'll replace 1 minus sine squared of theta with its Pythagorean relative cosine squared of theta, and I'll put that over sine of theta. And now what we have on the left hand side equals what we have on the right hand side. So that is the end of that proof. And there are a couple good examples of doing proofs that involve fractions.